Hello viewers, in today's class we are going to discuss an important inequality using the concept of increasing and decreasing functions, right? So here in this session we'll solve or we'll prove this inequality, that is the log of x is greater than 1 minus 1 over x for all x greater than 1. So let us see the application of derivatives in proving these kind of inequalities, right? So the first step is to frame a suitable function here. So here what we will do, we'll take a function f of x that is equal to a log of x minus 1 plus 1 over x, right? So we can frame the function using the inequality itself, and if we take these two terms to this side, we'll get log of x minus 1 plus 1 over x. So we can take this function f of x as log x minus 1 plus 1 over x. So let us find out the derivative of f of x. So f prime of x is now equal to, the derivative of log x is 1 over x, the derivative of 1 is 0, and the derivative of 1 over x is minus 1 over x square, right? So here we have 1 over x minus 1 over x square, that is we can take the LCM here. So x square is the LCM, and here we have x minus 1, right? So this is the derivative of this function. Now see, here the derivative is greater than 0 for all values of x which are greater than 1, right? So the derivative is positive whenever x takes the values greater than 1, and here the denominator x square is already positive. So to make f prime of x greater than 0, x has to be greater than 1. So we conclude that f of x, this function is an increasing function in the for all values of x greater than 1, because for x greater than 1 the derivative is greater than 0 or positive, right? So a function is said to be an increasing function if the derivative is positive for the values of x, right? So now let us make use of another definition of increasing function, right? Now see, if we have 2 points in the domain of the function f of x, and if x1 is greater than x2, then the function is said to be an increasing function if f of x1 is also greater than f of x2, right? So this is another definition of increasing function, right? So if we have 2 points in the domain of f of x, x1 and x2, and if x1 is greater than x2 implies that fx1 is greater than fx2, then the function is said to be increasing function. So here what we will do, we'll take this x as x1, right? And this 1 as x2. So we have x greater than 1, it means x1 is greater than x2, right? So what we'll do, we'll take x1 as x and x2 as 1, so that we have x greater than 1 as we have x1 greater than x2, right? And since we have already shown that this function f of x is an increasing function, so f of x1 should be greater than f of x2, right? So x1 is x, so we have f of x greater than f of x2. x2 is 1, right? So now we have f of x greater than f of 1. So let us find out the value of f of 1. by substituting x is equal to 1. So f of 1 is equal to log of 1 minus 1 plus 1 over 1. Log of 1 is 0, and here we have minus 1 plus 1, that is equal to 0. So f of 1 is equal to 0. So here taking f of 1 is equal to 0, we have f of x greater than 0, right? Now taking f of x as log of x minus 1 plus 1 over x, and this is greater than 0. Now taking these two terms to the right hand side, we can now write log of x is greater than 1 minus 1 over x, and this is the required inequality, right? So we have log of x greater than 1 minus 1 over x for all values of x greater than 1.